Hello all, I hope you are doing well. Today we are gonna look on the IP version 4 addressing, its structure and classes. This presentation is done under the guidance of Mrs. Suvarna Gaikwad. It covers IP version 4 addressing. Basically, IP version 4 is a foundational networking technology. It is very critical and important for internal connections and communications. IP version 4 is used in over 94% of global network infrastructure. It was developed in 1981 by DARPA. Moving forward, let's look up on some basics of IP version 4 addresses. It is basically a 32-bit binary address, that is, it uses 32-bit binary address system. Secondly, it provides a unique identifier for networking devices. Next, addresses under IP version 4 are represented in dotted decimal form, that is, for example, 192.168.1.1. There are over 4.2 billion possible unique addresses under IP version 4. The address space is divided into network and host portions. Moving forward, we would focus on the address structure that it has or incorporates. Basically, it has 4 octets, that is, it is composed, the addresses are composed of 4 octets. Next, the network portion. The network portion is something that identifies the network. Thirdly, the host portion identifies the specific device. Binary representation involved enables the routing, and the subnet mask defines the boundary between the network as well as the host. Moving forward to the IPv4 address classes, it basically has class A, B, C, D, and E. Class A has a range of 1 to 126, that is, it contains 126 networks, which could incorporate 16.7 million hosts. Moving forward to class B, its range is 128 to 191. It incorporates over 16,384 networks and has over 65,000 hosts. Class C ranges from 192 to 223. It has 2.1 million networks, and it could incorporate 254 hosts. Moving forward to Class D. Class D addresses are basically used for multi-classes, whereas Class E addresses are gradually experimental. Moving forward, just to take a look upon the private IP address ranges, Class A ranges from 10.0.0 to 10.255.255.255. Class B ranges from 172.16.0.0 to 172.31.255.255, and likewise Class C ranges from this range. So I hope you all know what these are. Basically, the address format that it represents, like as we saw earlier, the 32-bit address format that is incorporated in the IPv4. This is the format in which Class A, B, and C private IP addresses are ranged into. Private IP addresses are usually used into local networks, and they are not routable on the public internet for obvious reasons, hence like the obvious name, that is private IP address. And NAT relies on private addresses. Moving forward, IP version 4 address exhaustion, that is, it has some limitations, that is limited space, because it often experiences limited address space depletion. Like addresses were depleted by 2011, that is, the older versions are depleted, and temporary fixes to like maybe a temporary solution for these problems are NAT as well as CIDR are the temporary solutions, whereas long-term solutions is IP version 4 adoption. Like an estimated of 25% of global network will be using IP version 6 by 2025. Uh, to focus on the future of IP addressing, as we discussed earlier, IP version 4 is the like gonna be the future of IP addressing, where we'll experience a gradual transition to it. It will have a 128-bit addressing system. It will have enhanced security features as well as better support for IoT, that's Internet of Things. IP version 6 offers 340 undecillion unique addresses, which is quite a lot for networking. That is actually expected for networking. Hence, it will enhance the support for IoT and mobile network. Okay, that's it for today. Thank you so much. I appreciate your attention and hope you found this information useful and you may use this in your further applications. Thank you.